right, this video is about scientific notation. Scientific notation is a way of representing really big or really small numbers, so it's a shorthand for that. When you have a number in scientific notation, it's always going to be in the format some coefficient times 10 to some power. This number in front always needs to be greater than or equal to 1 and less than 10. So the easiest way to learn how to do this is just by example. So I am just going to do several examples for you so you can see how to take a large number or a really small number and put it in this scientific notation format. So for example, if you have the number, let's say 320,000, you are going to take the decimal. All whole numbers have a decimal. It's just at the end of the whole number. And you move the decimal place so that you have that original coefficient number that's between 1 and 10. So we're going to move this 1, 2, 3, 4, 5 spaces to make that original number 3.2. And then since we moved it 5 spaces, our exponent is a 5. So this number in scientific notation is 3.2 times 10 to the 5th. Here's another example. Say you have the number 562.4. And I want to put that in scientific notation. Well, I need to move the decimal 1, 2 spaces, because I always need my original number to be in between 1 and 10. Usually that just means moving the decimal so there's like one number in front. So it's going to be 5.624 times 10, and since I moved it twice, it's to the second power. Say I have 721 million. I'm going to take this and I'm going to move it 1, 2, 3, 4, 5, 6, 7, 8 spaces. So my number is 7.21 times 10 to the 8th. Now, all 3 examples, I gave you large numbers. So we were moving the decimal space to the left, and our exponent was a positive. When you have small numbers, so numbers that are smaller than 1, like 0.0041, it's going to work the same way, just this time you're going to move the decimal to the right, and your exponent's going to be negative. So this is going to be 1, 2, 3, so it's 4.1, and it's times 10 to the negative 3. When you start with a small number, your exponents are negative. So 0.0001684. So again, I'm taking my decimal, I'm moving it 1, 2, 3, 4, 5, 6. Or sorry, I just want to move it so that I'm creating a number that's between 1 and 10. So in this case, I've just got to move it to right here, because by making this number 1.684, that's my number that's between 1 and 10. So I want to stop when I get to here. So I only moved it 1, 2, 3, 4 spaces. So times 10 to the negative 4. So again, I'm going to move it 1, 2, 3, 4. I stop there so that my number's 2.96, and then it's times 10 to the negative 4. If you're going the other way, so say you're given the number in scientific notation and they want you to write it in standard form, then you're going to have something like 3.7 times 10 to the 5. And they say, okay, this is scientific notation. And I know it's scientific notation because I have this number in between 1 and 10. I have a times 10 to some power. Well, with this, you're going to undo what we were doing before. So since this says 10 to the 5th, that means that decimal got moved 5 times. We just have to move it back. So we're going to have 3, 7, but we're taking this decimal and we're moving it 1, 2, 3, 4, 5. And we just need to fill these spaces in with zeros. So the answer to this in standard notation is 370,000. Because we took that decimal and we moved it back 5 spaces. And I just remember that when the number is positive, you're making the number larger. So that is that. Give you another example. Say 2.98 times 10 to the 3. So I have to move my decimal 3 spaces. And I'm moving it 3 spaces to the right because I need to make this number larger since it's a positive exponent. So it's 298, and let's see, we're doing that 1, 2, 3. So I need to add one more 0 there, and that is my answer. When my scientific notation number has a negative exponent, that means that I've got to move the decimal 4 spaces, but I've got to move it 4 spaces to make the number smaller. So this decimal is getting moved 1, 2, 3, 4 places, which means I'm going to have each one of these little bumps I made is going to have to be a 0. You can always check your answer by, once you have it in this standard form, and it doesn't matter if you put the 0 in front or not, but once you have it in this standard, you can always check. If I moved that decimal 1, 2, 3, 4 places, that would get me that 3.24 times 10 to the negative 4. So 6.2 times 10 to the negative 3. That means take this decimal and move it 3 spaces to the left. It's negative, so you're making the number smaller. So we're moving it 1, 2, 3. That is your answer. We'll do one more with a positive. Say you have 5 times 10 to the 4th. This time it's a positive 4. Whenever it's just a whole number, the decimal is right after it. That means I'm moving it 4 spaces to the right. It's positive, so I'm making it bigger. So I'm going to have 1, 2, 3, 4, which means I need 4 zeros, which means that's my answer.